See, the one thing I try not to say is I don't try not to start off with all rights or so, because it's just a filler. So. Sucks when we get a lot of time, but I don't know if it's been that much time. I went back, I looked at our last update of Duke, it was a month ago. So we could give that a leniency of 4 to 6 weeks. We had intent of bringing Duke as a roller to the Off-Road Expo for PRP. I looked at it, it was on this table last time in the video. If you guys haven't seen the update of it before, then go back and look at the last one, but it was here. It was fixtured to the table, and it was the grave digger A-pillar tubes going down, and then there was nothing in the front, just the bulkhead, the plate like formation of that, up to the upper arm pivots floating. We have done pretty good load of work to this thing. Here's the deal with projects. If you think about, like, because remember, it's the classic thing. The first 80% takes 20% of the time, or you could even say like the first 90% takes 10% of the time, and the last 10% takes 90% of the time. And if you look at it, the easy way to digest a lot of that too is, okay, if it takes, you know, how long does it take to fit a 3.5 foot section of tube? It could take you 30 minutes. It could take less. It could take a little longer. Even if you equate that to an hour, and you work a 50-hour week into this thing, this is what we usually do, is we pull 50s on all these cars. Think about how much of a footprint you're going to be able to construct just on that principle. And then you build a bracket. And this bracket is complex, and it's holding something, maybe X and, you know, XYZ, it's holding it level in the car, and it's got to grab 2 different surfaces, off tangent, you know, all this stuff. That bracket could take you 8 hours. So think about, once you start, like, this is the easy part. I think this is the easiest part for a builder or a shop to construct, is the portion where it's a roller. Getting all the primary appendages and all the accessories on that are just the primary accessories. The next step is the secondary accessories. And then the next step, at least kind of textbook, would be, you know, headers, exhaust, sheet metal, and then like your detailed accessories from there. Everything has a place. These things, especially this one is super narrow. If I could look from the front, I want to equate this to being as narrow as a Volkswagen. But if you really look at that, you know, you have your track width, which can be your reference to like what a truck would want to be for width. And I know this will still stick out, but this is about 92 or 93 outside the tires. And then you look at that, you know, and you have this tiny little thing, and it's super similar to like a Volkswagen Bug. It fits a 6'4" person. That was the greatest thing, is with Dan, the owner. Dan got to bring his family to Off-Road Expo. They all got to check it out. He also got to bring Colton. We had a custom car seat made for the back that fits into the PRP seat. And then Dan got in there, and that was my biggest gamble. Is he was busy for some weeks, and we couldn't logistically get him down here when we were constructing the seat mounts. But I did everything I could to get a good educated answer on where to put the seat for him. Not just where to put it, but where it would clear for a helmet, where it would clear for race and passing tech, for all the sanctions. So that's what we got in here, and he got in, and it's incredible. Like, it looks so tight, but when you get in there, his headroom and his footroom is awesome. So that's the win. I'm like, where do we start? Okay, so I know for sure we had these tubes. We had like all of our stuff we could build out because we were waiting on the front suspension. So I think that's the best thing to start on. I expressed the shock mounts in the rear and something that would tie in. So what Jason with International Race Car supplies, which makes this easy, and this is like what we're gonna be doing from here on out. It's getting this lower bulkhead and Y-frame assembly, already has the geometry in it, already has the instant center and the live center and everything, the wheelbase, the track width already set. And then we build up from there. So we had this portion of the bulkhead floating, and then all of the structure from here up is all us. And everything is tailored, again, to what works, not just with the body, how the engine gets out, and then where the shocks need to be, the bump stops need to be. We did a pretty creative fixturing solution for the bump stops when we built this, where these caps that go on the upper arm, this is like a stainless cap for the compression. We actually machined a portion here that was a slug that we put in the can, right? So you have this can, it's not built into the chassis anymore, and it's bolting into here, and then we compress this right where it needs to be, space the stuff out where we needed it, and then we built everything on the fixture table to be tied into there. There's rolls, and I'm sure you'll see it with the B-roll, but there's also rolls from this point outward that reflect the shapes of the Willys. All of this stuff is on a really nice complex rolled system. You don't want to get too far ahead of yourself with that. So like I try to run some straights in areas just to tie things back together so it doesn't turn into like a full rock buggy. But you know, all of our stuff here assembled, built most of this. We went through a pretty heavy thrash. When you get opportunities like the Off-Road Expo or SEMA or something, and you can get a car to a milestone, not necessarily completed, but just to a milestone, it's a great like exercise to get that done. And it turns into logistics, you know, and you accelerate your planning more than you usually would. Where like for us, we get, you know, I bring the guys in, I go, okay, here's the time that we have. This is the resources that we can put into this. This is how many guys we can feasibly use on this while still floating other cars, you know, and here's what we want to get done. And then we go through and we stand here, we brainstorm a complete list, take the time it needs to take to do that. I get a list going, and then we start to prioritize needs and wants, you know, what we need to do. Then we go through and I mark symbols on there of things, because we don't just go through what needs to be done, we go through what needs to be ordered, and then we start to itemize those things, you know. So I'll put a symbol on there of what needs to be ordered, and then I have my cut list I can pull from there to get on to orders. The guys know where they're going to start building. Then we go all the way down to the day, because we go, okay, this thing needs to roll in. We need to have this A roller on Friday morning. Our cutoff time is this. So for this amount, we need to have this much done, so then I can flip the car over, because part of this is, for this particular instance, welding was a huge thing. So the guys needed to get as much as they could done, and then I needed to weld on it. And I needed to flip it upside down so we could weld everything upside down as well, especially up into the shock mounts in here. This stuff, like, we don't have a rotisserie, and I don't necessarily know if we need one, but every time we build a chassis, we flip it upside down and I weld it. And then, you know, we have to think logistically too. If I'm welding on stuff while people are working on stuff, what portions do I have to get through? It's an awesome exercise. As far as the welding on this stuff, it's all double passed. Colin rooted everything and prepped it all, and then I came in and did the final pass on that stuff. And I know just for my final pass, roughly 100 hours straight. So you got to think probably the root passing, it's not as time consuming, so we're probably talking 150 hours just in welding the entire car. That's a tremendous amount of plate work and preparation. So constructed the chassis, ran a lot of nods to design, as far as you'll see the plate work, radial gussets, landed the engine where it needed to be. That was the other variable as we were waiting on the ID Designs front kit, all the accessory drive. So sourced all that. Dave is one of the best in the industry, I think, with having parts and knowledge. So we just sent a guy to get that stuff. That scooched our engine back a little further than I thought we were going to be. but it's all good. We did all the front plate. Now we have all the mid plate because some of this has been done since Off-Road Expo, but I'll just kind of run through it. Part of the goal with this thing is getting as much done as we can, and with the shell off or the body off, and also bringing the amount of having to take the body on and off down to a minimum, because with that, the body is kind of flimsy still. It's only 3 sides, right? So it's a shell that moves around. It's a longer shell, it's chopped, it's got steel work done into it, so anytime we have to move it with the forklift, it's a risk. And it's also just upsetting the surfaces. It's not fixtured enough until it gets on this car. So we really try to nail as much as we can in here before that shell goes on, because that also closes out a large window of work. Once that shell goes on, it's going to get welded onto the car. All the sheet metal will tie in from the chassis to the cab, and then it's on and it's on. So we're really in a stage here of just getting as much as we can done. And I think the appropriate way to do that is to close out all of the inside, close out the sheet metal. The headers and stuff will have to be a hybrid because we have to use the body for some of that information. Everything we place in here, especially because the chassis is so narrow and like the occupant seating is primary, like everything falls into play with this more than anything we've built. It's extremely tight. So there's ways to get wind where it still feels good for the occupants, but everything has a home. It's not like you have a lot of options. So like this is our Resto Mod. This is a Haymaker S. This is a little more compact. Same thing, we have to figure out how this thing's gonna go in. We know that we're gonna have a panel under the seat that comes off, and this is gonna have to go into here. And then where this lives, we know that we're gonna have 8 exits on this thing that all have to have hosing, that all have to go somewhere, right? So you can't, like earlier building cars, something that's really exciting and fun to do is the floors and the tin work. And you just start laying stuff down based on what's gonna be clean and streamlined. And you don't really, at least for myself, take into consideration the plumbing, especially like an AC that's under a seat. There's things that have to go forward. A lot of the plumbing, like with the radiator and the fuel cell in the back, the jack system, there's lines that have to go in. And then another thing that people miss on, and I'm gonna include myself on that stuff, is wiring. You gotta figure out where your harness is gonna go. Building chassis and doing the tin work is like the easy level of it. Then you start to think, okay, how do you do this effectively? And why I have this here is because we have elements that we have to think about. The HVAC system can't be in the elements. So then you go, okay, well, we're gonna have to seal a partition off, but then there's lines that have to go through here to go to the back. We have the belly on here, and then we have the ducting. Where's the ducting gonna go? We have 8 different sections of 2-inch hose that have to rip through here, and then you also have to be able to service this. So there's like layers and channels and shapes that are all dictated by that. And same, like there's a shelf here, right? You can see like there's 125 plate. This shelf is a support floor. You can see there's an angle that's going upwards towards the front of the car on the tube work. So the floor will kind of taper narrower, but that's so we can get lines and things under here. We've already even built this chassis. When we started laying all the tubes in here, we were already thinking about oil lines, fuel lines, water lines going through the back. Where are they gonna go? We're gonna do hard lines in as many places as we can, but how are we gonna get them in there? How are we gonna fish them? How do we alleviate having too many connections? And how is all that gonna be constructed, all while thinking about the tin work? So I hope this makes sense. It's just a lot. And it's the next, like every time we build a car, we get another opportunity to do it better. And that's like why I go back on reference, because I remember like, even on the exotic or something, it's just like the panel work took over my brain for design and not so much the engineering of planning of what needs to happen and dictating the shapes of the panel work based on what's going to come following that stuff. So that's what we're doing here. We're packaging this in a way that's going to complement all the accessories. We have the HVAC for the passenger side, and then we have 2 fire suppression, 2 10-pound Safecraft bottles that'll go on the other side. Now we go back and you look at a lot of this stuff. This is Colin starting, you know, a lot of this where it's tin work. It's all broken down because I haven't been able to get in here and final weld everything. And we're gonna shit the bed if I don't come in here and root pass and final weld everything, you know, 360 instead of like, you know, the way you do it, right, is you'd put a panel in here and then you just weld what you can get to, and you're gonna miss so much. So I stopped Colin with the tin work portion of this so I can come in here and weld all this stuff out before he comes back. And that's just like, this is where we're at in process while we're filming this. So he's got everything laid out over here. The other thing is too, like the finish work, if you guys ever wonder about the graining on this stuff, this is a finish that I adapted to doing from structural steel and architectural steel. We used to use a thing called a burnisher, and when I do like big platforms and stairs and things like that, we did a lot of aluminum, big C-channel aluminum, and I would use this burnisher to get the grain back. It was very important on the finish work, so I've adapted that to this, and this is the, you know, what you'd use. There's good, better, best with this stuff. I would always get a Metabo if you guys wanted to buy the best version, but you know, like this might be an Eastwood or something, and it gets you by, you know, and you can get quality wheels on these things. This is a multi-compound, so this is a Scotch plus like a sandpaper interweaved in there, and this is what gets you that grain. If you ever see us, like we do like a DA on part of the finish and then the step down we do grain, this is your move. It's no secret, so I'd rather just share that with you guys because it's such a helpful tool. And a lot of that, like, you got to get your wins where you need them and then be efficient, especially for the customer, on your finish level on stuff, and running that grain through there is a lot more effective than having to DA some stuff. So in the end, it'll be super uniform. All the tin work in here will have all that same grain all the way through. Something I like to do is I like to tack all the panels with steel rod. You know, you'll end up doing a lot of the welding with silicone bronze, but the steel rod, you get a smaller tack, and then when you go to weld, you know, if you tack everything like on every inch, you know, you tack a whole seam together, say like this. If you tack this guy every inch with silicone bronze, it's a large, soft dab of rod. So when you go to weld it, unless you're gonna sand all those down and finish them, you're going over and you're making like a speed bump in the seam of your weld. With the steel rod, the other thing is it requires less. So you can come in here and there's less rod, so then when you weld it, you get a nice clean hit through the silicone bronze, and on top of that, it doesn't pop. So when you're forming all your panels and you're getting stuff together, sometimes that silicone bronze will snap, like it'll crack a tack. So that's just been the move, but everything will be sealed in silicone bronze. So for this area, I think what you'd expect next update is all closed out. You'll see the HVAC in there, you'll see the bottles in that side, and then you'll probably see the floor closed out. The false or the elevated floor is only on the passenger side. The driver's side, we're just gonna give Dan as much foot room as he can, or whoever's driving that, so we're gonna drop that all the way down, and we're gonna run most of the plumbing and the wiring and stuff on one side, where it's got a little more height built into the floor to go under, but Dan's side, or the driver's side, will favor space, just so you'll feel that. Every inch counts. Same deal with that, like if you can open up, you know, dimensionally 1 inch on everything, just to make it feel better, when it's all closed in, it's gonna count. Something else to look at right now while we're here. We're gonna work with K&N filters, not just on the Dakar prototype, but also on the wagon. One of the issues we ran into, and I appreciate you, Sean Black, for helping me with this, is the factory intake manifold. It's a horizontal mount. The throttle body is horizontal, so it comes up pretty high, and then you're gonna have to run a filter element, and then that thing boosts everything up through the profile of the hood, and we don't want that. Then you go, okay, well, what do? I'm running a horizontal style thing like this. If I wanna go vertical and I wanna flip the throttle body 90 degrees, typical would go out towards the front of the car. And then we have the ID Designs set up here, which is pretty much for a big block. So they're anticipating an 8 stack or something large on top of the engine for filtration. So you go, okay, I'm gonna get an intake manifold that puts the throttle body out there, but now I have all the ID Designs bracketry up here where, you know, it's favoring service. So like the alternator and the AC compressor are up high on the front of the engine. So then the throttle body that's supposed to come out there, that doesn't clear. You can't run intake out of there. So we go, okay, what about running it backwards? So this is a Hogan's billet intake manifold. I called, I think it's Bill. I wanna say Bill Hogan, and asked him if this thing is asymmetrical. Can we just flip this thing and run everything towards the rear of the car, run the throttle body vertical off the rear, and then run a Motion Raceworks T throttle body fitting that will take the intakes and pretty much split them out to each side. And that's what we have here. So this already brought our height, 50% lower now. So now we can get all our packaging. We were gonna set up to do some kind of a cross member through here. So now we're gonna get that win. Anything else that we wanna mount under here, because the cowl, the shell of the body, you know, it's the windscreen, it's a split window. So there's a piece of glass, little chrome trim, and then it does like a shape like this. Very similar to what we have here. This kind of follows the sheet metal and it draws out here. So we have room to mount things now. And then we have whatever we need to do. If we have to do some kind of an emergency cooler mount in here, then we have the space for that as well. I say that because I think we have everything planned. This is gonna be a long update because it's just, there's a lot of stuff. What you guys will see, and we should have all this going next time, is you'll see a throttle body from Motion Raceworks. You'll see a T, like an all billet black T. It's actually a perfect fit in here. So it'll throw, you know, a service for an intake tube on each side with like a Wiggins. So you'll see that thing split. That'll all be mounted right here. This will be cable driven, not wire. And then what we're gonna wanna work on is getting tubing going through here. There's packaging stuff. I guess that's gonna be the repeat thing here. And I think that's how it is with all the cars. There's headers to think about and there's intake to think about. There'll be an intake tube. It'll be symmetrical, at least on the exit of the car. I can't guarantee that it's gonna be symmetrical because of the steering shaft on the driver's side. So, you know, bottom line is you're gonna have a run from the intake manifold out here and it's gonna pop through. And then what we're gonna do is those jerry cans that this thing originally came with, these old like rusty Indiana Jones looking things, we're gonna replicate that. We'll scan it, we'll replicate it, we'll 3D print it, we'll put perforated holes on it where it can breathe from the backside so it's not pulling direct air. And then K&N's gonna build us a filter element. So pretty much what you'll have is, you know, you'll have a pickup and then the body will go on, and then whatever that box is gonna go into here and it's gonna latch into here, and there's gonna be a 3D printed jerry can. You'll undo 2 latches, it'll be hinged, you'll open it or it'll fall this way, whichever way, and then there'll be like a filter element, like a flat filter element, like a factory car, something where it's not a conical piece. And you'll be able to service both sides of this thing, but it'll look like a jerry can. That's one portion of this. The next portion is headers. The benefit we have with the whole vision and the design on this car is that we don't have to run the headers down towards the footwell, and we don't have to run them down the middle of the car. We get to run them on the outside of the chassis out here to complement the running boards and the fenders. So really, we're gonna grab all of the primaries. Again, you know, think about wherever this air intake tube has to be. I would imagine it's somewhere here. That has to do its thing, and then all of the header work has to come out towards the front here, but it'll go up. It'll never draw down until it gets to the outside of the car, and then it'll collect, and then it'll collect into something big. I would imagine with a 632, the primary is gonna be 2 1/4 or 2 3/8 or 2 5/16, something large like that. So You know, you'll have 4 of those gathering, they'll group, they'll merge, and then we'll probably have a 4-inch exhaust running all the way to the end, doubling as the running board. If it's gonna be a rolled design, then we're gonna roll that whole piece of 4-inch all the way through. Maybe put a muffler on, I'll talk to Dan about that, or put 4 on, 2 per side. Let's talk about this intersection. There's obviously a spine here, and that's the easy thing to go over, but we'll save that till I'm done. This center section, it's a very unique shape, but it's that shape to favor the transmission. We wanted to make sure the transmission came out, and something we opted for that's different here is running a built like an in-car mid plate. What I mean by that is a lot of times this mid plate, the engine, the setup we run on these cars, they don't run traditional block mounts. This is the most effective way to capture an engine and the drivetrain, is a front plate and a mid plate, and then usually another rear plate near the underdrive or the tail shaft. So this is living in the car. This is a piece of chromoly. It's 1/2 inch thick. We cut it on the plasma table. And then what's going on here is, instead of your traditional tube that comes down and you bolt this thing together, you have to understand that the real estate that you're dealing with in here is far from the ability to run a tube straight down with a tab off the tube with a removable aluminum mid plate that bolts to that. It's tremendous. So this is living in here, welded in. All of this is box chromoly plate. There's no openings in it. This is grabbing the mid plate. This section is floating over the trans. These are raised so you can put your hand in through here from the underside of the car and you can grab these bolts. Everything is built from trial by fire here of making sure this trans comes out and it separates and you're not having to do spooky stuff. I'll go over the trans mount or the underdrive mount that I have over here. The other thing to note is we've been waiting on this intake, and then we're going to be waiting on the throttle body and the T-plow, because we don't have a pickup yet going up to here. And as much as I feel comfortable with this being an isolated event that's strong enough, I'd still like to see something run from the windshield tube. Like ideally, you'd want to run right from the intrusion bar, close this junction out, tied down into the mid plate. But based on what we have here, like once you see this in, it is built exactly to fit here. So we have to figure out what kind of tasteful plate work or something we're going to run to tie this in. I don't think it's going to just be a tube, but that'll be subject to when we get this stuff in. So we kind of have to move in an order of parts and packaging. This is our spine. I wanted this to be a prominent design. You can stay here, Joey. I'm going to go from the other side. Part of this, in like my end vision here, is there's so much design work that's complementing that. The Willys itself, when you look at it, it's classic Art Deco styling. It's a 49, a lot of stamped bead rolled things, but also there's a lot of just radial stuff. And I kind of took that and just ran with it on this, where this whole thing, the design direction, is based on radial stuff. We started with the detail on the, like above the upper arm pivot. You can see there's kind of that like half of a bullet going through there. And that's what set the tone, and then the same with the cutouts for the jacks. And you start pivoting on that. And then it just starts, you want that same language to go through everything. Same with all the radial gussets. So the spine is something that's going to be an actual visual cue and a detail even when the car is complete. The deal here is I don't want to run a huge, big instrument panel and dash. I'd like to have 2 very tidy pods come up based off of this. So when you have upholstery, you have tin work down here and carpet, and it closes out through here like this piece if you want to see it. Right, so it gives you an indicator of kind of where our upholstery wants to be. And same thing, this is going to be all covered. We'll figure out what's going on here, and we're going to have to seal this. But then once that's there, this is going to be something you see. You have a nice upholstered piece. This is powder coated, and you have this kind of spatial gap. and it's nice. You can get in the car. It gives you this strength feeling of this central spine running through the car. So it was something we had to navigate. Originally, I wanted it to be larger where it would go all the way back, but you can't fit third-person feet if this thing's right in there. So I think this will all come together and make sense, but it's definitely, this whole center design is just based straight up on the transmission and underdrive and what we can get. Same with the seats and the seat mounts and how we're gonna get the bolts in. Like with Vivian, I remember the seats being really difficult to get in and out of Vivian. And I know the seats aren't something that you change often, but those things stick with you. You know, when you start working on it, you're like, oh man, we can do this better. And same thing, you apply all of the lessons from previous builds into building it better and more effectively. So that's why some of these shapes are like this, and it'll all come together. This is our Super 80 reed case. Rancho Drivetrain Engineering is going to be building this for us. Mentioned it before, paddle shifted, 4L80, tube works underdrive from Jason, and then this is what we talked about in the chassis. So this is a structural sculpted piece. You know, I think Joey will probably take B-roll of it, but what you have here is this is a 2-inch tube with a slight roll in it. So 2-inch 120 wall chromoly tube. This is a 1-inch 120 wall chromoly tube. Then there's 125 or 1/8-inch chromoly plate in here that's cut a little inset of tangent so we can get a full pin pass in here. Where the weld, you know, like why I say cut inwards is so this turns into a structural piece. Because if you just had this plate going up clean and then you welded it and then you sanded the weld, you just lost all the integrity of it structurally. So there's a heater of a weld going through here and then it's blended into the shape. This is your underdrive mount. So this picks up on the underdrive here, and this is gonna live on the trans. So when you go to pull this trans, you're not gonna pull it from the ears here. You're gonna pull it from the 3 bolts per side. Is it 3 or 4? Yeah, it's 3. 3 bolts per side on the chassis. And then you'll pull it from all of the mid plate and bell housing mounts. And then this thing will just pop out and drop down. So this is the part that lives in the car. But you'll see where that goes. So that goes right into there, into that middle place. Everything is prepped to final weld, and this is all final welded. So we'll get all that going and then bolt this back in when the trans goes in, but that's your missing component down there in the middle. It's just a similar orientation there right there. The lifesaver for welding chassis. You know, so anytime with TIG welding, for me at least, it's about having my hands comfortable. I don't mind if I'm twisted up in a chassis and uncomfortable. I can use the pedal with a lot of my foot, like in different ways. So it's really like just my hand rest. And if I want to be able to, when the heat from where you're welding turns into something that's in your brain, it affects how you weld. I don't care who you are. It's just, it goes into your programming. And I used to do stuff, even like working at other shops where I would get these hero blisters on my fingers, and I called them commitment blisters, where I'd sit into the heat and I would go all the way through the process of, oh my God, that hurts. Holy shit, that hurts. Oh, it's burning me. Oh, I've been burnt. Oh, it doesn't hurt as bad. And you go through all that whole thing. And then you have these ugly remnants of these commitment blisters, and then it affects your weld quality. So I try to give myself every opportunity I can to get the best result, and a lot of the time is using one of these where I can just stay in it and I can have a consistent pull on all the junction because of these. This used to come with the Harbor Freight pipe threading kit, which the pipe threader is the same thing that you use to convert your manual tube roller to electric. And it was like a freebie in there. And I don't know why they have it. I don't know what the actual use is, but it's a rest and it works perfect. I think they have these on Amazon now. Jason Hurd did make one, but it was too clunky for me. It was too billet and just not as agile as this old school looking piece. Let's talk about this. So the rear portion of this thing, same thought process. We knew that we'd have two primary things that go back here. The first one is the fuel cell, not a fuel tank, but a fuel cell. On top of that would be the radiator and part of the cooling. So those were the main real estate grabs for the back of the chassis. And then we go, okay, well, where's the spare gonna go? Is it gonna have a spare? Yes, it will have a spare. That will go outside the cab. So there'll be, you know, your shell. What would look like a rear hatch would not be anything factory. It'll be like a carbon rear hatch. There'll be extraction and venting, not just for the fuel, but for the cooling package, which I'll talk about. And I have the fuel cell can here, so we'll look at this. But just to think about it, we wanted to get as much space as we could. Even building the tube work out, we built the tube work thinking about how cohesive that would be with getting the fuel cell can out. Because if you do things in a way where, you know, the one way you do things that you want to avoid is you want to avoid building a structure that landlocks the fuel cell, where then, you know, you could build a box in there, but how are you going to get it out? The second is you do that, and then you have to just build a fuel cell can that has spatial voids somewhere because you didn't engineer it where it just looks like a can that's sitting in a non-tailored chassis. Sometimes, like with Ryan Felicia's Raptor, when I built that was 2017, and I did this back half, and he supplied the fuel cell. And then we kind of just build that thing, and then we build like around it and to it. But this is a custom can. We knew we could get a win with the shapes, and we knew we wanted to maximize the capacity by building the chassis in a way that can facilitate this can coming in and out. So a lot of the planes and stuff of this are all complementary to getting this can in and out. Something else we wanted to do, we wanted to stress a void here with 2-track. I know with the exotic pre-runner, that was the first instance where I thought about that. When these things compress and they G out and they're into the rear, like this tube, this line that goes through here, oftentimes sees a substantial amount of damage, particularly in the middle, because of 2-track. A lot of the desert, and this is for a lot of you guys if you're not familiar with it, a lot of desert and a lot of race course and stuff you end up on is 2-track, meaning there's two really deep ruts. And a lot of times in the middle of that, you know, the rocks usually, most of the time, in most good instances, are on the outside or in the middle. And when the car is going through 2-track and it's compressing, this main tube always takes the dingers. There's always damage, it always needs repairs. It's just, that's a problematic area. And if you're building the car where it hangs down really low, then you're doubly as screwed. Something to note on that, when this car is at full compression, the line of the trailing arm from the front of the pivot of the trailing arm all the way to the back here is all one consistent angle. So think about the trailing arm being compressed. This is the front of the car. The trailing arm's compressed. This is the axle center line. And then the chassis is a perfect angle all the way through. So it's never gonna have that hang up. But just in case, this is a 2-track clearance. There's no tube going through the middle of this. And when this fuel cell, hey, you guys, this is Hank. This is our 10-year-old pit bull. He's had babies for us and we have them. I got Hank when Logan is 12. Man, so Hank's 11. I got Hank when Logan was about a year old and he was this big. And we thought he was going to be a bully breed pit, which is like more gnarly, thicker, jacked looking thing. And he ended up being a perfect size pit bull, but he's been the greatest dog we've ever had. I used to be the guy that didn't like pit bulls. And I was like, no, they're bad dogs. They're not good around kids. And this, like, just the stereotype, right? And my wife Taylor was the one that's like, you're wrong. We need to get him a pit bull. And I wanted to get him like a lab or a golden retriever or something, which I could count on. And Hank's been one of the best things ever. And he's been with me through all the years and struggles. And I've counted on him to get me through some pretty dark times. And he's my best friend. Hi. So anyways, he carries sticks. And if you ever see him, he favors carrying 4x4 pieces of wood everywhere or whatever he can get. And he's really spatially aware of them. He doesn't like wreck into the cars or anything. He tilts his head and he kind of manipulates wherever he needs to go, so he's not taking your shins out or anything. So there's a 2-track void here and it tapers, but it, you know, when we put this fuel cell in, you will see that there's a shape change here that happens. These registers, same Nat, there's these registers here. There's registers here that they double down as gussets, but really what they're doing is they're just holding the corner of the can and they're holding the sides, you know, and then you'll see this is a register, and this is just again to support the capacity. This lower floor, you know, the gnarliest load the fuel cell gets is compression loads. But that's not to say it doesn't get upset from going up and it doesn't side slosh. You know, I think primary load would be the one that compresses and does the like direct G-force laterally, and then your side load is the next slosh in a fuel cell. And you know, that's why with a fuel tank you do baffles. So it kind of breaks up that slosh. But a fuel tank is just a bladder, or a fuel cell is just a bladder. So we'll get into that. I'm gonna put that thing in here. The other thing is the radiator, and I think that's something we can talk about. If you look at the standoffs here, these are temporary because we needed to figure out what we were gonna do for hold downs for the fuel cell. But I didn't want to build anything more out here because we just don't have the information. So once the body goes on, we took measurements of like where the shell is and what's going to happen. And we knew that we're going to have a safe zone here to just prep a tube and continue whatever's going to go on with the rear bumper, with the tire gate. You know, like I said, the spare tire is going to be here and it's going to swing. There'll be a winch or a floor jack. I know we need to incorporate a winch somewhere remote mounted. And then I also know we need to put a floor jack. So I don't know on that spare thing. Imagine all the tangents I've gone off. I think we started a tangent about talking about this thing and didn't even close that out. So it's a lot of information. You know, there'll be a closeout in between the body. You know, the original style Willys was a wagon, top window, and then rear, what would you call it, tailgate? So you'd have that. This is going to be something different because it's not going to be needing the accessibility like that. And I think what we're going to do is just have like a carbon panel that goes in here that still has some nice shapes for the Willys, but it has the spare kind of incorporated where it's almost like, my analogy that works for me is I always think about if this was like, this is drastic, but a slab of melted, you know, or warm butter, and you push the spare into it and it kind of rippled on the side. So it shows an indicator of where the spare lives. That's what it'll be here. And then you'll have extraction shapes that'll be similar to the Willys body, that'll have mesh, that'll let all the air come out. The cooler we'll talk about once the fuel cell goes in, and I think I might as well just start getting that in right now. I would think, so we just got the Bronco fuel cell back and it doesn't have this upper hump. So, and that's 75 gallons. So this might be 85 or 90 gallons. There's obviously some unique shape in this thing. A lot of this will make sense once we put it in the car. We have this thing where it's not all the way in. Just to show the register, you can see it's gonna start to pin down onto the center portion, and then you can see this register too, right? So I'm gonna kind of help it in there. And then you'll get a nice little, Joey will trip over the stool as that thing clicks. And you'll see the register in here. So that's step one. You know, just like I said, you can see there's still a zone here where this is secure against the tube work. The other thing that we wanted to stress was getting some design wins. So you'll see the step. The reason you put bead rolls or steps into things, it's like the same concept I've expressed before, is rigidity. You can take a thin piece of material and you can make it more rigid if you upset the surface. The greatest example is if you take a piece of paper and it's floppy. And you, I mean, how about this? You take a piece of paper, it's floppy, and then you just take the piece of paper and you crinkle it, and then you undo it, it's rigid, or at least better than it was, or if you folded it in half or something. And it's the same thing with sheet metal, so it's about giving it rigidity. When this thing sloshes and it has the bladder in there, you just want to try to give the material, you know, a vast expanse of the material, the best chance it can, and not, you know, pull out and tweak itself. But what we do when we do those steps is try to get design wins. And if you see like the step here complements this main runner, this is our main, this is the breakup, you know, it complements this. There's areas on the top and on the back side that I'm gonna grab some pieces for you to show you. So this is like a temporary fixture, right? Feel me? Temporary. This is something so incremental that we've learned with stuff is we try to fixture everything we can because it moves. You just, some of it's obvious, right? Like running a big pass through here, it's gonna wanna contract, but things move more than you would imagine with steel. And it expands and it contracts, and it sometimes it'll throw you for a curveball. With structural steel, we used to anticipate the weld, you know, and a lot of it was more geometric. So, you know, for a big beam, sometimes you put a back bend in it. So then when you weld that area, you'd already have it pre-bent. So then when you pull that out, it goes back to flat. And you could kind of do some premeditated counter fixturing. But a lot of this stuff, we just want to do a placeholder. So what these pieces are, these are 1-inch 120 wall hold downs. Functional design is what we stress. And the same thing with the fuel cell. When we do these layouts, we don't have the hold down structure in place yet, but that doesn't mean that we don't talk about it and plan and pre-run where things are gonna go, so then we know, just like these steps. You know, we wanna run complementary steps that are on plane with, you know, our support system. So when that goes in, that's running center to the steps. The back of this we can look at too. All these little things require the same level of attention, if not more, than the bigger stuff to figure out planning, because we got to think, okay, we can't have a tab that's interrupting where the can comes out of here. You know, so we think about where we can get wins. You know, these are machine parts in here. So same thing. This will go in here and it'll bolt up and it squeezes this thing in here. We leave these long. These are like our spook holes, we call them. And we'll cut that down and taper it, but we just build it long so we can land everything to it. And then everything on here gets bolted in and it's countersunk. So that means that the hardware in here is flush and we machine all these pieces on the lathe. And then everything's just this trimmed cradle that also functions as a design aesthetic because of the layout. Another design aesthetic here is this hump. This is for capacity, but then what I need to do is figure out, you know, we can't just build any shape. The height and the spacing on the footprint on the top of this thing is for pickup, return, vent, and fill. All of that, I have researched what plate we're gonna use for the fuel cell, what that's gonna have up there, and then I think about, okay, well, when we do a fill here, what's that gonna look like? Where's that gonna exit out of the rear of the car? You know, what's gonna be here? Where's the spare gonna be? How much room do we need to get something where we can mount up here and it can come out of the car so we don't have to open the back hatch to fill it? And where it can transition down, still mount to here, where all this stuff can go into the top so this whole footprint fits the fill. Then the next thing is this shape. Obviously, this is here for a reason too. What's gonna happen is there's gonna be a big PWR North America cooler that goes in here. I spoke with them, we had like a meeting based on the demands of this car, and they're gonna package everything specifically for this car. The radiator back here is gonna be on an angle. The depth of this and the height here is all specifically designed for what they think is optimal for the car. This is gonna be a dual fan. It's gonna have the AC condenser built into it. It'll have the bottom portion of it be an oil cooler. The oil sump tank right here is gonna be cohesive with the plumbing. So it'll all kind of intersect back here, same with the filter. So all the work for the oil is gonna be done up here except just going into the engine and coming out of the engine. But the water itself, you know, this is gonna be at an angle. The depth here with the fans on it is going to be built to this depth and what we have. So there's a footprint that's living here that's not here yet. The other thing is they're running 2 big fans. So those 2 big fans are going to be on each side of this hump, and then that's going to impose the ventilation going out of the hatch, if that all makes sense. So we're thinking about this a couple steps ahead of what we're actually building, just so it all falls in line. Things to think about for next time. We have strike pads in here. We have limit straps, lower, upper. We're running triples in the rear, so we'll have 6 limit straps total on the rear axle. We'll have 4 limit straps up front. All that stuff needs final welding. The strike pad needs final welding. I think we're gonna focus on tin work. Like I said, just veering on getting everything we can put into the chassis before we need to put the body back on. I'll start planning for the exhaust and the headers and get all that stuff ordered. But really, I think what you're gonna be able to count on is a lot more tin work. The AC in, the 2 fire bottles in, the floors in, and probably a lot of the stuff back here too. We want to stress working on this thing and getting as much stuff done as we possibly can before the body goes on, because then it absolutely cripples our efficiency with working on the car. You know, and there'll be a whole SUV cab right here. So really, you're just getting in anywhere is gonna suck. With a lot of the sheet metal on this, I wanna focus on, and I talked about it before, is getting the exterior portion layered instead of the interior. A lot of times when people go to build a car, the easy way is to go into the inside of the cab and stab everything, on the top of the tubes on the inside of the cabin. And then when you look at it from the back side, like especially the back wall or some of the underside of a tube chassis, there's these voids. There's the tube, and then there's the plate, and like mud, debris, everything can just easily pack up into those areas. It's super hard to clean. So what I'd like to do is stress getting all of the tin as much as we can in most areas under the car and on the sides of the car on the outside. The upholstery and the carpet and everything is gonna cover the inside, where you don't get those style points or the functionality points nearly as heavy as if you look under the underside of the car and it's completely streamlined sheet metal everywhere. And there's no tubes and extra crevices for crap to build up. And it's super easy to clean, and it just looks super streamlined. One of the things you might be thinking or wanting to know about is like where we're gonna get air. With a radiator specifically, radiator wants airflow. Sometimes with like an oil cooler or a trans cooler, you can bury them into some pretty stagnant places because just the flow of that particular system and the oil, it's happy just getting a fan pulling some stuff through. Radiator, not the case. So we're gonna have this big unit angled in here. I don't wanna close off windows just to put a duct or a scoop. It takes away from the vision of the car. Having transparent windows is a thing. So what I'd like to see out of this, and hopefully we get the win, is there's a mid window here. So there's the rear quarter window, there's the front window, and there's a mid window. And what I'd like to do is scan it, and I like to have like an injection mold or a vacuum mold where it's a transparent piece of acrylic that turns into a 3-dimensional shape that goes in here. And then we have a pickup for it that seals up. All the cabin, you have to think there's a rear wall partition here, and then everything forward of that has to be sealed. So no dust, no water, nothing, is all the cabin space. And then back here is open, where we have to have airflow from here, airflow from up top, all dropping into this to get that for the cooler to be happy. And then everything has to exit too, because if it just sits in there with turbulence, then it's still not gonna have a pass through. So I'd like to see something where there's ducting through here, but it's on a transparent window. And then you get a wind, because then you can see all the shock mount and everything else, and there's visibility. The other thing to think about too, if you're in that third seat, it's always important to me to not make that person feel claustrophobic. It's the same thing with tubes. when you're doing a cage and you're building a back seat section, like not running this crazy structure that's like this impending tube structure where the third occupant is not connected to the people that are sitting up front. When you're a passenger in a car and the driver's there, you're very connected because this is the guy that's controlling the vehicle and you feel kind of cohesive with that. But sometimes when you get into a spot that's more reserved, it's very easy to start feeling disconnected and then you start feeling unsafe. And that's the thing that you want to create this sense of security in these things because they do things that are pretty dangerous. So having this blocked off, you know, creates its own challenges. I'd like to also pull air from the top somehow. I don't know what this is going to look like, but there definitely won't be any scoops. You know, I always say that's a positive shape. There'll be a negative shape, so something that comes in instead of something that pokes out to grab this stuff. That's our footprint under the chassis. The circular areas here are the jack pads. That's for the day car jacks that are in there from Geyser Brothers. Rick, thank you for your support. We've been running those. That's our third car we've done with the Geyser jacks or the day car jacks. So everything you see here is the cutout and the planning for the skid. It's on different surfaces. It's kind of got a boat hole thing going up on the sides towards the rockers. So what we're doing here is Colin makes a big template that's somewhat accurate. It's enough to start cutting on, but it's really to look at layout, to look at where we're going to plan for our hardware locations to mount these things. Then we also think about stuff like what needs to come off first. We want to make sure that the center section where the transmission is the thing that comes off the easiest. We don't need, like with Vivian, we built this big pan that goes into the whole car and it's seamless. It's got a big boat hole design and it's got these big gnarly brakes in it, but it's like this, it's this 1/4 inch thing and it's gnarly. And to get this thing in, like for Vivian specifically, things like this are, again, you know, lessons going down the road. You always want to build stuff clean, and serviceability starts to, it can either be complemented by building it clean or it can hurt it. And you know, like with Vivian, if you guys remember, we built this big gnarly boat hole skid plate, followed the front cross member, had some pretty significant angle changes in it, and we built it all one piece, gnarly brakes on it. It's all registered into the car, and it's 1/4 inch, so it weighs a considerable amount for one guy to handle it. So, you know, like revising that one, we wanted to put this into 3 pieces, and the center section being, you know, the transmission area, that needs to come out first. The rest of the stuff can live in the car accordingly. Everything we do with this, we don't do nut certs on anything, and we definitely don't do capture nuts on the backside like a typical bolt and nut. We always use a nut plate. That's a stronger, much more substantial thing for anything. The only time we ever use a nut cert, we never do it on anything outside the chassis. It's only like very minimal stuff like interior, some kind of interior trim or something like that, but nut certs will fail. And a nut plate, like an aircraft nut plate, is what we use, and then a floating nut plate for this stuff gives you a little leeway on finding your bolts, especially if some of the skid plate takes rock damage and it skews your plate. You actually can, you know, have some space to get that bolt in and out. There's a lot here. Next time you check in, there's probably gonna be a lot here still. On a side note, Fab Diaries, interactive. I always tell you guys to leave a comment. Tell us what you'd like to see more of. I think the #1 thing that always comes up is we wanna see you working. And it's in my brain too. Very cool, oh, thanks for the update. Can we see you building the stuff? That is 100% our priority on figuring out how to do that. It's a ton of resources to have someone here full-time filming that stuff. So what it's gonna look like is I'm gonna have to get into a flow where I can kind of shoot a vlog with you guys, shoot some routine, maybe a week of work. I don't know if it's gonna be just one dedicated project like the Fab Diaries was, or if it's gonna be something where you guys just cruise with me. And every time, you know, Colin's working on this thing, I bring you over. You're with us on our dialogue and our planning and our execution. Then sometimes I get some cuts of everybody working. But I promise that our intent here is to triple down with YouTube and the investment into YouTube, and to get you guys as much behind the scenes working content and daily life content as we can. I promise that. It's my word. I'm really going to lean into that stuff. And so I know it's been a slow burn, and I know I've talked about the Fab Diaries coming back, and it's really just about how we're gonna pivot that and how to make that investment make sense. When this stuff does drop, I'll probably say it in there, it's gonna be trial and error. We're gonna figure out what works, what doesn't work, what you guys like, what you wanna see more of, and I'm gonna include you guys to mold this channel into something that you really enjoy. So thank you so much for your support. Here's Duke, on to the next week.